And welcome everybody to the Daily Space Weather. Let's see what the sun's been up to. First, a colorized magnetogram to see a fairly stable sunspot group there in the southern hemisphere. It's beta class, and we only see one set of umbrae. There are two different polarity umbrae, but only one named sunspot currently on the solar disk. The 10.7 centimeter radial flux at 82. So there's a 1 year chart of that. And for you new viewers, the radial flux is very proportional to sunspot number. So there's the previous cycle, solar cycle 24, as well as the beginning of solar cycle 25, which we're just barely 1 year into. And we see a significant uptick there. Next, we'll look at the 94 angstroms full disk view. And we see some coronal holes in the north, significant ones. And all of the major activity there happening in the southern hemisphere. No major solar flares or anything like that happening. And let's get on to some more stuff. Such as what's going on at Lagrange point 5. Well, here's what's going on at Lagrange point 5. We don't see any coronal mass ejections happening on either side of the solar disk. A little bit of a prominence coming out around here. And you can see this filament. We've got filaments on both the non-Earth side and the Earth side. For you new viewers, the Earth is out in this direction. And let me go back to the previous image there. Stereo A is located there at Lagrange point 5. By the way, thanks to our patrons, a true source of funding. Please consider becoming a patron at patreon.com/smashamash. We recommend that you join at the $3 or higher per month tier, as we'll be eliminating our lowest two tiers of $1 and $2 at the end of the month. Patreon.com/smashamash. Next, looking at a full disk view in 193 angstroms, you see that large coronal hole in the northern hemisphere there. Great view of that. And let's take a look at some more data as we've shortened up the video a little bit today. We will be showing you some more helio viewers toward the end, so stay tuned for that. And make sure you stay tuned, make sure you tune in to our solstice stream, which will happen during the exact moment of the solstice, which will be on December 21st at 5:02 and 20 seconds Eastern Standard Time, and we're located in Lehigh Valley, Pennsylvania. It'll be a YouTube exclusive at youtube.com/smashamash. Thanks everybody who's subscribed. Please press like and subscribe if you enjoy the content. Share on your social media. Thanks to our new subscribers and our old subscribers, our loyal crew, the Smash team. By the way, we nailed our weather forecast yesterday, got almost exactly the amount of snow we forecasted, and it even stopped almost exactly at the time we forecasted it to stop. Major accumulation stopping around 2 a.m. local time. And we are streaming live to Twitch. Don't forget to check out our other social media and so on. Twitch.tv/smashamash. And don't forget to visit our own site, smashamash.com. You can find our social media links there. Next, looking at the real-time solar wind here. To see the solar wind speed quite low, having reached a low of all the way down to 262, I thought I saw. There we go. 262 kilometers a second. Now up a little bit higher than that to 270 kilometers a second or so. Solar wind density quite low at 3.35 protons per cubic centimeter. And we see some likely coronal hole magnetism happening here in the past 12 hours as well. KP index currently at 0. So let's take a look at some cosmic rays. First, we'll look at the Apatity Neutron Monitor and Barentsburg. Two fairly reliable cosmic ray monitors that seem to show legit data. There's Apatity, small downtick over the past 30 days there. There's Barentsburg, similar downtick over the past 30 days of Barentsburg. Next, we'll go farther south to Athens, Greece. Here's the Athens Neutron Monitor. And you can see a small downtick happening there over the past 30 days as well. Next, we'll go even farther south to Mexico City. There's a Mexico City Neutron Monitor. Slight downtick there. And next we'll look at Oulu, Finland, and DOMC, Antarctica. There's Oulu, Finland. Slightly down trending there at Oulu, mostly flat. And here's DOMC, Antarctica, somewhat of a downtrend there as well. Next, we'll look at the Geospace Magnetosphere movie. We're only going to show you pressure today, as there's not a whole lot going on. No major fluctuations. This is 4 hours of data based on the Space Weather Modeling Framework. And you see that slow solar wind velocity and low solar wind density reflected in the pressure. We don't see major magnetic perturbations on the ground either. Here's 4 hours of data on that. Ground magnetic perturbations. Nothing too exciting happening there. And it looks like the main changes in the Earth B field are happening right now over the Canadian North Pole as opposed to the Siberian one. And yes, there are 2 North Poles currently. And let's move on to some more stuff. Proton flux has been flatlined over the past 3 days. There's a chart of that, as measured by the GOES-16. Only one solar flare of note in the past 24 hours. This small B-class flare happened around 1340 Universal Time yesterday. Here's a star chart. And you can, if you're up before dawn, you can see Venus is rising there. Please know the difference between Uranus and a hole in the ground. When Uranus gets into the constellation of Taurus, be very, very scared. And please, folks, do not join the Church of Moloch. Next, looking at a chart of the solar system. There's where things are now. There's where things will be in a week. Next, some magnetic data for you here. There's the GOES magnetometer over the past 3 days. Fairly smooth there, and the Earth should be in the North Pole current sheet. Keep in mind the data is 1 hour and 13 minutes old and can change with absolutely no warning. Give that a minute to load. There we are streaming live. Actually, the data's 1 hour and 59 minutes old, and you can see that South Pole magnetism evaporating there. And the Earth a bit indecisive, but expect it to be in the North Pole oriented current sheet. Here's a line of sight coronal hole field plot. You can see in green in the northern hemisphere that large coronal hole. That is a North Pole oriented coronal hole. And here's another view which also shows you the solar poloidal fields. And the solar B field there shown in blue. Last but not least, we'll look at a coronal magnetic field plot. A field plot of the sun's atmosphere. Quite chaotic here. It's showing you closed potential field surface source lines in pink and open ones in black or purple. Next, we'll talk electrons. We don't really see any charging hazards here. No surprise there, as the electron flux is at quite low levels, not quite as low as forecasted, and NOAA continues to forecast even lower levels of electron flux. There's the 3-day chart of it as measured by the GOES-16. Here's a visualization. We see some small anomalies here over the northern portion of North America. And we tend to see more anomalies when we have very low levels of electron flux. And that'll give you an idea of where GPS errors should be located. Here's a diagram of the Van Allen belts and so on. It also shows you where that GPS satellite would be located, about 12,500 miles up. At the bottom of the outer Van Allen belt is where your GPS satellite would be. And here's another visualization of atmosphere layers. If you look at that red F over on the right side, that would be where the GOES-16 endeavors to make its measurements. It also shows you the penetration of electromagnetic radiation into the atmosphere, visible and infrared radiation, making it all the way down to make you feel warm if you're standing in the sun. Next, looking at the ionosphere layer. Let me load that up again here. And this is courtesy of the Australian Government Bureau of Meteorology. There's a visualization of the ionosphere, and it is a little bit anomalous there. You can see it's charged up at nighttime in the southern hemisphere as the southern hemisphere approaches summer. A little bit of southern hemisphere anomalies happening. There's the latest image, that one coming in at 10:45 Universal Time. Let's see which volcanoes have been erupting at volcanodiscovery.com. Abico is erupting. It's producing a 10,000-foot ash plume. Fuego exploding, 14,000-foot ash plume there. Sangay also exploding, 19,000-foot ash plume there. I think that's an uptick down there in Ecuador. Revenador, also in Ecuador, exploding, flight level 150, 15,000-foot ash plume. And continuous emissions from Sabancaya in Peru are a reminder to not attempt to pole vault the caldera. No major earthquakes over the past 24, although a significant number of deep ones. And the largest of the past 24, I believe, was this 5.6 at Peru. So here's one of the deep quakes I talked about. It's a 4.6 at Fiji at over 570 kilometers depth. A deep quake at Colombia there, a 4.9 magnitude at 151 kilometers depth. Another deep quake at Peru. A deep quake at Argentina. And nothing else to report. Let's look at the jet streams. There are the jet streams of the Western world. And we see some extreme meridional jet stream flow here. Jet streams are all over the place. Split in two, northwest of the Great Lakes. And some extreme bends in both hemispheres. Here are the jets of the eastern world. And you can see some extreme meridional jet stream flow there, such as this one here. That's an extreme bend in the Arctic North, as well as some serious kinks and bends in the southern hemisphere. And that data is from nullschool.net. I like to use Lightning Mapper. Not Lightning Mapper. lightningmaps.org when I hear thunder. And there's where the lightning strikes are happening. Here's a GO16 Lightning Mapper giving you a visualization. Most of the lightning around North America is in the Atlantic Ocean. Here's a pressure map. That's where we expect things to be tomorrow at noon. Here's where things are now. And you can see that nor'easter causing low pressure system taking its time moving up the New England coast. And that's the GFS forecast for pressure at 12 noon tomorrow. Eastern U.S. will be dominated by high pressure. Here's what's going on the Doppler radar, and you can see New England and New York still getting hammered by heavy bands of snow. The main band in this region right here, you can see that dark blue associated with that. And look for more meteorology videos coming in the next months. Here's what's going on in the cloud layer. It's too dark to see them with a visible satellite, so we use the 3.2 nanometers NASA GOES interactive shortwave radiation satellite to see where the clouds are when it's too dark to see them with the visible. And we use the water vapor to see all the water vapor, even that which is not condensed onto clouds. And thanks for flying American Smash Waves, folks. We've got bonus features. We're going to show you the colorized magnetogram, close-up, high-res, as well as the colorized magnetogram. The colorized magnetogram and the intensitygram. I don't know what I'm talking about. So there's the colorized magnetogram. And again, that sunspot has remained pretty stable here over the past 24. There's that sunspot. It's still beta class as we see some trailing umbrae that are opposite polarity. There's the lead polarity. It's south pole oriented. And let's look at the rest of the HelioViewer movies, as we've got two more for you. It's the 335 angstroms. And here's 171 angstroms. Thanks for tuning in. We are out. Again, don't forget to press like and subscribe if you viewed on YouTube. Share on your social media. Tell your friends and foes about the channel. Possibly more content coming later today. And may that solar wind be at your back. And good morning, Tin Man. Thanks for leaving a comment from Oklahoma. We'll see you next time.